Hi, this is Miss Marion. We are going over Unit 4, Lesson 9. Go ahead and turn to page 130 and read the I can statement. I can use an expression to find when two things like height are the same in a real-world situation. Go ahead and give yourself a sentence on how you feel about that, and then give yourself a number. Number 1, I don't remember. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So our goal for today is to create an equation in one variable to represent a situation in two conditions in a real world situation kind of thing. And then we're also going to go ahead and solve those and answer questions with those. All right, let's go ahead and turn to page 63 or 45. It should look like this. And it says, if you are babysitting, would you rather charge $5 for the first hour and $8 for additional, or charge $15 for the first hour and $6 for additional after that? And then explain your reasoning. So go ahead and pause, answer that question, and then go ahead and come back to me. All right, is there a correct answer on this? The answer is no. It really depends on you. And then also, I think it really depends on how long you're actually teaching. Or sorry, not teaching, but babysitting. And so really it depends on which one you want to go ahead and go with, and then also how long you're babysitting for a family. All right, one of the things I want to go ahead and go over, even though we talked about really depends on what you're looking at, I want to go ahead and have you understand how to kind of make an expression for both of the charges. And this is going to help you for your homework later today. So it charges $5 at first, and then it's $8 for additional hour. So it's going to be $8 and then times how many hours you have. So that's the first charge. The second charging is, we have $15 starting out for the first hour, and then $6 for the additional hour. So it's going to be 6 times H for the rest of it. So notice how the top one is 5 plus 8H. And then the bottom one is 15 plus 6H. And this is going to help us with our homework for later today. All right, let's go ahead and let's look at this table. We're on page 64 or 46. Should look like this. We have a table with time and then a tank 1 and tank 2. It says the amount of water in 2 tanks every 5 minutes is shown in the table. Describe what is happening in each tank. Either draw a picture, say it verbally, or write a few sentences. So look at tank 1, figure out what's going on. Look at tank 2, and then figure out what's going on. So go ahead and pause, and then come back to me. All right, let's go ahead and go through this. If we look at it, tank 1, right? We start at 25, 175, 325, 475, 625, and you kind of keep on going on here. So what is going on with tank 1? The water is increasing. Okay. All right, let's go ahead and let's look at tank 2. Starts at 1,000, goes to 900, goes to 800, goes to 700, goes to 600. What's going on with this tank? Tank 2, the water is decreasing or going down. So this one's going down, while the other one, it is going up. All right, let's look at number 2. Use the table to estimate when the tanks will have the same amount of water. So go ahead and pause, and then come back to me and see what you can find. So I'm going to go ahead and I'm going to look at this. And so it's like 475, 700, 625, 600. Oh, okay. So right now, where they're kind of almost be the same is going to be around 20 minutes. So I'm going to say about 20 minutes. Now, is it going to be over 20 minutes? Because if you look at it going over, this is 625, this is 600, and then it goes 775 and 500. So it's really more closer to 20 than any of the other two. So it's about 20 minutes. All right, let's go ahead and look at number 3. The amount of water in liters in tank 1 after T minutes is 30T plus 25. So they kind of gave us an expression for tank 1. The amount of water in liters for tank 2 after t minutes is negative 20t plus 1,000. Again, there's another expression for tank number 2. Find the time when the amount of water will be the same. What does that actually mean, be the same? So to me, that's saying, oh, it's going to kind of be like when they are equal. Okay, so really we're going to have tank 1 is going to equal tank 2. Well, let's write that down. So tank 1 is this stuff. So we have 30t plus 25. And it's going to equal tank 2. Tank 2 is this stuff, which is negative 20t plus 1,000. Okay, so now if we solve this equation, it's going to tell us when both of those are the same. So go ahead and pause right now, go ahead and solve this, and then come back and make sure you're doing it correctly. All right, let's go ahead and let's solve this. So step 1 was distributive property. Is there anything I need to distribute? No, not really. Step 2, we need to go ahead and combine terms together on the left-hand side. I can't add the 30t and 25. They're not exactly the same type of number. Can I add negative 20t and 1,000 together? No, they're not the same type of number. So can I go ahead and combine these together? No. Step 3 was go ahead and get all my variables on the left-hand side. So that means I want to go ahead and I want to take this negative 20t and I'm going to put them over here. So if that's a negative 20t, and I kind of want to make it 0, I want to go ahead and add 20t or give positive 20t's to both sides of the equation. 30t plus 20t is 50t. We still have plus 25. Positive and negative 20s, they make a 0. And I still have the 1,000. All right, next we want to go ahead and we want to have 25. He wants to be on the other side with the 1,000. 25 is adding. So then we are going to subtract 25 on both sides of the equation. Right? All right, so go ahead. Let's grab our calculator. Let's do 1,000 minus 25. And it's 975. Positive and negative 25, they go away, they make a 0, and then we have 50t. Remind yourself, 50 is multiplying by t, so then we are going to divide by 50 on both sides. 50 divided by 50 is 1, leaves t by himself, and then we're going to have 975 divided by 50, and that is going to be 19.5. So at 19.5 minutes, both tanks will be the same. We'll say we'll have the same amount of water. All right, so what we've done is we've looked at these different tanks, we've seen the equations for these different tanks, and then we're looking at it to see when they are the same. So we are going to go ahead and equal them, and then go ahead and solve for it. So we said it was about 20 minutes before, like when we were looking at it, just looking at the table. Now we actually know for sure it's 19.5 minutes. All right, let's go ahead and turn the page to 65 or 47. We are now going to talk about elevators. So a building has 2 elevators that go above and below ground. At a certain time of the day, the time travel it takes for elevator A to reach height h in meters is 0.8h plus 16 seconds. The time travel it takes for elevator B to reach the height in meters is negative 0.8h plus 12 seconds. So number 1, what is the height of the elevator at this time? So let's kind of think about that at this time. So have those elevators, have they moved at all? Has anybody pushed those buttons to call for that elevator and make it move? No. So our time right now is, our t is going to equal 0. So our time is 0. So what we're going to do is we're going to take the elevator A stuff, so 0.8h plus 16, and that all of that is going to equal 0. Our time is going to equal 0. Then we're going to take the elevator 2, or elevator B, negative 0.8h plus 12. We're also going to equal that to 0. And then we're going to solve for the h. And the h represents that height. So if we go ahead and we're going to solve for that height, we're going to solve each equation for h. So go ahead, pause right now, go ahead and solve those, and then come back and we'll actually do those together to make sure we're doing it correctly. All right, let's look at elevator A. So elevator A, do I have any distributive property to do? No. Do I have anything to combine together on the left-hand side? No. What about the right-hand side? No. So then our next step is go ahead and have all the variables on the left-hand side. Those are already there. So next thing is go ahead and we're going to do PEMDAS backwards. We're going to go ahead and put letters on one side, numbers on the other. And so we're going to go ahead and get it so that 16 needs to be with the 0. That is a positive 16. So we're going to go ahead and subtract off 16. We're going to have 0.8h equals positive negative 16. They make it 0. 0 minus 16 is negative 16. Then we want to go ahead. We want to get h by himself. 0.8 and h, they are multiplying. So we are going to divide. Grab 0.8 divided by 0.8 leaves h by itself. Grab your calculator. Let's do negative 16 divided by 0.8. And that's going to be negative 20. So what does that negative 20 actually mean? Well, that means that elevator at time 0 is going to be below ground 20 feet. Sorry, it's actually meters. So it's h is going to be, so it's 20 meters below ground. Okay. All right, let's go ahead and let's solve for B. So do we have distributive property to do? No. Do we have combined like terms on the left-hand side? No. What about the right-hand side? No. The h is on the left-hand side. The variables are on the left-hand side. We already have that. So that means the 12 wants to be with the 0. That is positive 12. So we're going to go ahead and subtract off 12. So we're going to have negative 0.8h, positive negative 12 make it 0. 0 minus 12 is negative 12. Remind yourself, negative 0.8 is multiplying h, so we are going to divide. Grab your calculator. Let's do negative 12 divided by 0.8. Oh, sorry, that's a negative divided by negative. And so h is going to be left by himself, and that's actually a positive 15. Well, what does that actually mean? That means that it is 15 meters above ground. Okay? So if it was negative, it's below ground. Positive, it's above ground. Because remember, those elevators can go above ground and below ground. All right, let's go ahead and look at number 2. How long would it take each elevator to reach ground level at this time? So ground level, that's a height. At ground level, we actually think of it as the height is going to be 0. All right, so let's use that information. So remember, elevator A is 0.8h plus 16 seconds. Let's take the h, and remember h is going to be 0. So we're going to do 0.8 multiplied by 0 plus 16. Grab your calculator. 0.8 times 0. 0.8 times 0 is 0. 0 plus 16 is 16. So what does this mean? That means when the height is 0, it took 16 seconds to make that elevator go to ground level. Let's try that with elevator 2. Elevator 2 was negative 0.8h plus 12. Remember, our height is going to be 0.8 multiplied by 0 and then plus 12. Negative 0.8 multiplied by 0 is 0. 0 plus 12 is 12. So it would take 12 seconds for elevator B to be at ground level where the H is 0. All right, let's look at number 3. If the two elevators travel towards one another, at what height do they pass each other, and then how long will it take? So remember, if they pass each other, that means eventually their stuff is going to equal. So let's go ahead and write down that sentence, that equation. So elevator A was the 0.8h plus 16. Elevator B was negative 0.8h plus 12. And let's go ahead and let's solve that and go ahead and figure out at what height do they pass each other. So pause right now and solve that and then come back to me. All right, we are solving this, right? So we want to go ahead. Do I have distributive property? No. Step number 2 was to go ahead and combine anything on the left-hand side. No, there's nothing to combine. Anything to combine on the right-hand side? No, there's nothing to combine. Step 3 was take our H's and we're going to put them all on the left-hand side. So if we look at it, the negative 0.8h wants to be on the left-hand side. How do we go ahead and move that person? Because it's negative, we want to make zeros, we're going to put positives with it. So let's grab our calculator and let's do 0.8 plus 0.8. And that is going to be 1.6h plus 16 equals positive and negative, make zeros, right? And then we still have that 12 left over. Let's go ahead and let's solve and get h's on one side, numbers on the other. That means that that positive 16 wants to be on the other side with the 12. He's adding or he's positive, so we're going to subtract it off. Oh, sorry, 16. So we're going to have 1.6h, positive negative 16 make zeros. And then what is 12 minus 16? 12 minus 16 is negative 4. Then remember, we want h and 1.6, they are multiplying. We want to get h by himself. So we're going to go ahead and divide by 1.6 on both sides. 1.6 divided by 1.6 is 1, it leaves h by itself. And then negative 4 divided by 1.6 is negative 2.5. And what does that mean? That is 2.5 meters below ground. So the second part of this is, okay, how long did it take for those to get there? So with elevator A, we're going to go ahead and we're going to put the negative 2.5 into the equation. So we have it as 0.8h plus 16, right? So we're going to do 0.88 multiplied by negative 2.5. Grab your calculator and then plus 16, right? And then grab your calculator. We're going to do 0.5 times negative 2.5. That's going to be negative 2. And then we're going to add it to 16. So elevator A is going to take at 14 seconds, the elevator will be below ground 2.5 meters. Now let's go ahead and put that negative 2.5 into elevator B. So I'm going to change my color. Let's do red. So elevator B, the equation was negative 0.8h plus 12. So we're going to do negative 0.8 multiplied by negative 2.5 and then plus 12. Grab your calculator. Let's do negative 0.8 times negative 2.5. That is 2 and then plus 12. 2 plus 12 is 14 seconds. So notice how on both of those, it takes 14 seconds for both elevators to kind of be at the same spot at the same time, and that will be below ground at 2.5 meters. All right, number 4. Number 4 says if you are underground parking at level 14 meters below ground, which elevator would reach you first? Okay, so remember, it is below ground. So if it's below ground, we're looking at it. And so that H is going to be negative 14. So go ahead and figure out A and elevator A, and then go ahead and figure out elevator B. So pause and then come back to me. All right, elevator A, its equation is 0.8H plus 16. So we're going to put in negative 14 for that height. And then we're going to take and we're going to say 0.8 times negative 14. That is negative 11.2. And then we're going to add 16 to that. So let's plus 16. And that is going to be 4.8. And so that will make it so that it is 4.8 seconds that it will take for the elevator A to go 14 meters below ground. Now let's go ahead and let's try it with elevator B. Elevator B, its equation is negative 0.8H plus 12. Again, we are doing 14 meters below ground, so we're going to multiply it by negative 14. So do negative 0.8 times negative 14. That is going to be a positive 11.2, and then plus 12. And then let's add 12 to that. And so it will take 23.2 seconds for elevator B to go 14 meters below ground. So which one's going to reach you first? That will be elevator A. So we've gone through some equations about the elevators, looking at it, seeing how long it will take for it to be at the same height, looking at it where the elevators start at the beginning, at time 0, where the height is. So we've been looking at all these different things, and with these equations, we've been looking at real-world applications. We use elevators all the time. Not in my house, but like when I go to the hospital, I use it. All right, so these are things that we can look at in our real-world situation itself. So remember, there are many different units and quantities and different things in math that we in real world that we can go ahead and know if they are the same, how long it takes for cars to go ahead and reach the same area, how long it will take you to be at the same spot if somebody left at St. George and you left in Sandy, went south, and the other person went north. All of these kind of things are things that people do look into as far as how long it takes and kind of transportation kind of things itself. So that was our goal today, is be able to go ahead and look at different quantities, see what happens with those when we equal them, when we have the same numbers and we put them in there to go ahead and figure out what is going on. So go ahead and turn to page 130 or 94. Go back and read Unit 4, Lesson 9's I can statement. I can use expressions to find when two things like height are the same in the real world situations. Write yourself a sentence about this I can statement, and then go ahead and give me your number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. All right, have a good day. Thank you. Bye.